there are so many learning sciences discoveries that just aren't being applied at scale. And that's really what learning engineering tries to do, is to move from the science of learning to scaled implementation of those findings.
I'm Celisa Steele.
I'm Jeff Cobb, and this is the Leading Learning Podcast.
Welcome to episode 331, which features a conversation with Jim Goodell. Jim is the Director of Innovation at Quality Information Partners, and he chairs the Learning Technology Standards Committee at the IEEE Standards Association and the IEEE Consortium on Learning Engineering, also known as ICICLE. Jim is the co-editor of Learning Engineering Toolkit, evidence-based practices from the learning sciences, instructional design, and beyond. Jim and I talk mostly about the Learning Engineering Toolkit, what prompted the book, how it took shape, what learning engineering is, the relationship between learning engineering and learning science, and how learning engineering can be used to design and improve learning experiences. Jim is a passionate proponent of learning engineering, and he brings deep understanding of and much experience with learning engineering to our conversation. His hope is that you, dear listener, will consider turning your learning business into a learning engineering business. I spoke with Jim in September 2022. I think we should start first by a definition of learning engineering. So how do you define learning engineering, and how do you distinguish it from something like learning design, which might perhaps be a more familiar term to listeners?
Learning engineering is a process and a practice that applies the learning sciences using human-centered engineering design methodologies and data-informed decision-making to support learners in their development. And you don't have to take my word for that, because the IEEE Standards Association and ICICLE organization under IEEE developed that definition. And your listeners may be wondering, IEEE, that sounds familiar. Well, you may not recognize IEEE, but you do recognize Wi-Fi and Bluetooth. And IEEE was the standards organization that developed the standards behind those technologies.
And so when you think about learning engineering, given that definition that comes from, the IEEE and the work that they have done, how do you distinguish it from something like learning design?
Yes. So learning design overlaps with learning engineering, and listeners who consider themselves learning designers may already be doing learning engineering. So you think about that definition and what those parts, applying the learning sciences, using human-centered design, using engineering mindsets and data-informed decision-making. So if what you do involves those ingredients, then you might be doing learning engineering. And data-informed decision-making, sure, there are different levels of fidelity. In learning engineering, we consider both the data instrumentation side of data and the analytics side of data. And the learning engineering process is an iterative process. So we assume that data collected in one iteration is going to inform improvement of the next iteration of a product.
So you have just put out this book, The Learning Engineering Toolkit. I'm curious to know what prompted the book, and why do you feel like the book is needed now? Why is this the right moment for it?
So I guess I'll go back to, it started as a personal journey, because over a decade ago, I was working for an organization, the Center for Educational Leadership and Technology, and a mentor who worked with the Detroit Public Schools pointed me to some learning science research discoveries, and I was astonished by some of the things that I was learning about how people learn. And I made it a quest to learn as much as I could about what we can know about how people learn. And what I discovered in that process was there are so many learning sciences discoveries that just aren't being applied at scale. And that's really what learning engineering tries to do, is to move from the science of learning to scaled implementation of those findings. And during this process, I learned that there was an organization called ICICLE, the IEEE IC Consortium for Learning Engineering, that was starting in 2017. And this group was meeting and having debates about the definition of learning engineering. And we weren't really getting to a clear definition, but I had heard that the term learning engineering was over 50 years old. Over 50 years ago, a guy named Herb Simon, who's a Nobel laureate and was at Carnegie Mellon University, coined this term. And I knew about some learning businesses that had spun out of Carnegie Mellon University that were doing learning engineering, and I wanted to learn more. So I took some vacation time, took a few vacation days, used some frequent flyer miles, flew down to Pittsburgh, and visited with a whole bunch of people and interviewed them about their understanding of what this thing called learning engineering means. And I was with Mark Lee, and Jody List joined me for some of the interviews, but we interviewed a whole bunch of people at Carnegie Mellon and outside of Carnegie Mellon at businesses like Acrobatic, Carnegie Learning, and Duolingo, and heard their take on what learning engineering is. And that trip really was the beginning of the development of this book.
Well, thanks for sharing that. It began as this personal journey, and I'm sure it must be very satisfying to now have the book in your hands and to know that it's come to this fruition where all that you've learned can then be helpful, and all that the other collaborators and contributors have learned can share, and now others can apply it. I want to go back to the definition that you shared of learning engineering, because I think that definition points pretty clearly to the connection between learning engineering and learning science. You just also talked about that connection in sharing your personal journey. And so, I think that one of the things that you talk about and point to is that there have been all these discoveries that come out of learning science. Some of them are surprised you 10 years ago, but that they aren't necessarily being applied at scale, as you explained there, and that being sort of what learning engineering can hopefully do is help apply those at scale. But would you talk about what you see as the reasons why those discoveries from learning science haven't been applied? What's sort of preventing that from happening? And then how can learning engineering help us overcome those obstacles that learning science has maybe faced in the past?
Sure. Learning is a complex endeavor, but there are other areas of engineering, other domains of engineering that have addressed complex endeavors. Part of what's holding us back is we're using processes that are more in art than science and engineering. Part of it is we're kind of stuck in often being constrained in ways that we really just need to get something out the door. So we use a learning design process like ADDIE that can often be used as, it could be used as an iterative process, but often the constraints force us to do a one and done kind of design development. So learning engineering is in its infancy, and like other areas of engineering, the benefits are going to grow over time. So I think of an area like electronics engineering. And back in the 1950s, there were some components that electronics engineers standardized on, things like resistors and capacitors and inductors and then transistors. And those parts had tolerances. So the electronics engineers knew that they could buy some parts, they were reusable parts, but they could be used to develop different kinds of electronics, radios and televisions or whatever was being developed. But as the profession and the technology got better, they could start packing more and more of the transistors onto integrated circuits. But those integrated circuits also had tolerances, so they knew that they could use them not just for one-time building of an electronics device, but they can manufacture millions of those devices, and they know that the parts are going to do the job that they're meant to do. So there's a real opportunity for learning engineering over time to develop into a set of reusable practices and components that can allow us to do much more with the resources we have and create better learning for everyone.
At Tagoras, we're experts in the global business of lifelong learning, and we use our expertise to help clients better understand their markets, connect with new customers, make the right investment decisions, and grow their learning businesses. We achieve these goals through expert market assessment, strategy formulation, and platform selection services. If you're looking for a partner to help your learning business achieve greater reach, revenue, and impact, learn more at tagoras.com/services.
So maybe we can get a little bit into how learning engineering works. And I'm thinking in particular that maybe you can give us an overview of the learning engineering process model and sort of walk us through that at least a high level.
Sure. We can provide this in the podcast notes, yes?
Yes, absolutely. We'll make sure to include a diagram there. So thank you for that, Jim. But yes, listeners can go there, and so they'll be able to see what you're describing verbally here.
Okay. So at the center of the process diagram for learning engineering is a circle that has the word challenge in it. And that's the starting place. We start with a challenge. We always want to, as much as possible, understand the challenge or the problem we're trying to solve. And that challenge doesn't exist in a vacuum. It exists within a context. So the context includes the learners that we're designing for or solving a problem for. It includes the team that is developing the solution. It includes environmental factors and cultural factors, motivational aspects, everything that has to do with whatever the challenge is. Now, where we go next, the learning engineering process is an iterative process, but the challenge defines where we go next. So it may be moving out to the creation phase. The creation phase is not just about designing, it's about designing and developing iteratively, and it involves creating not just learning experiences, but also implementation plans and data instrumentation, or the means by which we're going to collect data so that we can inform better learning and better iterations of the next product. So the challenge might also lead us directly to implementation. Maybe we already have a product and we want to implement it in a new way or collect additional data so we'll better understand how to improve the product. And then we move into investigation. Investigation is where we look at the data and we figure out what it tells us about how we can improve the product in the next iteration cycle.
And so I know you've stressed a couple times there, but I will stress it as well. So the idea is that this is a continual iterative process. You're always sort of taking what you learn at any phase, feeding it back in so that you're kind of having this continuous improvement, right?
That's right. And ideally, it would involve some experimentation, some A/B testing. So when we implement, we may implement 2 different variations of a learning solution and use the data collected to figure out which of those implementations work best for which kinds of learners.
I know that one of the points that comes across very clearly in the toolkit is that learning engineering is not only about technology. Technology can certainly be a part of it, but that learning engineering, can be applied beyond e-learning or technology-enhanced learning. And so could you just talk about how learning engineering can be used in all situations where learning happens and maybe give us an example or two of of what learning engineering might be focused on if it's not dealing with technology?
Yes, that's a great question. And that also goes into the difference between learning design and learning engineering, because there are cases where learning engineering is trying to solve different kinds of problems than learning designers might think are in the scope of what they do. And one example that we used in the book that addresses both the technology side of, or lack of technology, and lack of a learning experience design is a story about the West African country of the Gambia. And their challenge was just getting kids to school. The government had eliminated fees for schooling and had built more schools, but kids just weren't getting to school. And so they needed to find out why. So they did some surveys, collected some data, and they found that parents of young children weren't comfortable with having their kids walk to school for 3 kilometers or more. So the solution turned out to be donkey carts. So it wasn't anything to do with learning experience design. It wasn't anything to do with high technology. It was donkey carts. And you might wonder, well, how is this learning engineering? Did they iterate on this? Well, they did. They found the first version 1.0 of the donkey carts were too heavy and didn't have some safety features. So they built a version 2.0 using local materials, lighter donkey carts with seat belts and gates. And they found that the older students could drive the donkey carts and bring the younger students to school. And that was a learning engineering solution.
I do love that example because, as you pointed out, it does make this distinction between learning engineering and learning design a little bit clearer. And I think it's also perhaps an exciting area for learning businesses to explore this idea of what are the obstacles that are preventing learners from engaging with resources you already have out there. And, maybe it is the cost or the time involved in traveling to a place-based event, for example. So what can you do to potentially, provide the donkey cart equivalent to your learners there to help get them there?
Yeah, that's right. Often the challenge is not about the learning experience itself. It's about these external factors such as organizational culture, and human performance is impacted by assumptions built into organizational culture or social and cultural factors. One example that I'm aware of is that certain cultures, parents feel more or less comfortable communicating with staff from schools. And so one school district decided that it was best, rather than to bring in parents to parents nights in the school building, they went out to the community. And so they found a solution to that challenge. But there are similar kinds of things in terms of learning businesses where something just like mindsets might be the barrier to the learning that needs to take place.
I know that you make the argument that, ethics and values play a role in learning engineering. And in fact, there's a whole chapter in the toolkit called Learning Engineering is Ethical. So would you unpack for us a little bit that assertion and explain some of the ethical considerations that we need to take into account when engineering learning?
Sure. One of the big ones is the collection of data and how we're going to use those data. Most of the most valuable learning data has personally identifiable information when it's collected. And we should be protecting the privacy of our learners. And there's ways of doing that to maintain the richness of the data, even at the clickstream data level, which is really where it's really valuable, while protecting the privacy of the learners. There are some other areas. One example story used in the book had to do with giving credit where it's due. And there was a university that the professors had to grapple with the idea that when they had a new discovery that really came from some students and they wrote about it in academic papers, they should credit the students, even though they weren't at the same academic level or considered faculty. So there are a lot of cases like that where in actually each stage of the learning engineering process has ethical considerations that the book goes into.
So in terms of trying to make this even more practical for our listeners, I think there's already a lot of ideas and nuggets in here. But for a learning business that wants to adopt a learning engineering approach, what are some of the actions you would recommend that they take to get started down that road?
Probably a good place to start is to look at the learning engineering process and look at the definition. Compare that to what you're already doing and see if there are some low-hanging fruit where you can add a little bit of learning engineering to what you're already doing. So it might be, well, maybe we can add one cycle of iteration if we do some rapid development and get the product or content in front of real learners sooner. And then by the time our deadline of actually delivering this product, we'll have improved upon just doing a one-off. Looking at the learning engineering definition, applying the learning sciences, using human-centered engineering design methodologies, data-informed decision-making. How can we better apply the learning sciences? Can we use a checklist with our next project to see, are we considering the right scientific discoveries and incorporate them into our design? How can we instrument data so that we have that feedback loop that we need?
I like this recommendation of first sort of assessing what you're already doing. And to your point, like even if the term is new, organizations may already be doing a fair amount of learning engineering. So perhaps just becoming conscious of what they're already doing and then looking at some of the gaps and where they can potentially add in more, and then going back to that definition and, thinking about the human-centered design, the emphasis on data, all of that makes a lot of sense. So thank you for those suggestions. Since this is the Leading Learning podcast, I do always like to ask guests about their own learning. And so I'm curious to know how you approach your own lifelong learning. And given what we're talking about, I'm also curious to know if you are approaching your own lifelong learning through a learning engineering lens. Are you trying to engineer what you're doing with your own lifelong learning?
Yes, absolutely. So I guess my earlier example of wanting to discover about learning sciences was one example, but probably a better example is during the production of the book, I realized that I had a real gap on the learning analytics side. The book defines data-informed decision-making in two parts. We actually broke it into two chapters because it was so important. The first part is data instrumentation, and that is designing and developing how we're going to collect data about learning experiences. I know on an earlier podcast, you had Megan Torrance talking about XAPI, and that is a great tool for doing standardized way of doing data instrumentation. I knew a lot about the instrumentation side. I did not know, or I realized that I had gaps on the analytics side. So I did some research, and I was aware of one of the pioneers in the field of education data mining and learning analytics was Ryan Baker, and he had published what he calls a MOOT, a massively open online textbook for learning analytics, and it's actually a series of videos. It's called a textbook, but it's a series of videos. So I took the time to go through that series of videos and with the practical lens of how can I use this knowledge not only for myself, but for the book. And I realized, like the learning engineering process, that the first time I learned something like that, it would not be complete or 100% correct. So I reached out to some other authors like Steve Ritter, and Steve and I worked together on taking the information from Ryan's course and turning it into a process model that can be used by everyone that has the book now. And then I also realized that even though Steve was an expert, it could be even better if we ran it by Ryan Baker. So Ryan Baker is at the University of Pennsylvania, and you can look up his online moot for learning analytics and education data mining. And Ryan gave us some additional feedback to make the model even better. And that's what is in the book now.
I'm curious to know how you went about structuring the book and whether you sort of had the topics in mind and then went out and sought contributors and collaborators, or whether you kind of, it reads like this who's who of learning when you look at the table of contents, or did you sort of go to those people, those connections in your personal, network and sort of say, I'm thinking about this, what do you think we should write about? Was it people or ideas first, or is it hard to say?
It was a little bit of both. So the organization of the first half of the book, the foundations chapters, is based on the definition of learning engineering. So the first chapter is learning engineering as a process. The second chapter is learning engineering applies to learning sciences. This, I bet, sounds familiar because it comes directly from the definition. The third chapter is learning engineering is engineering, and it talks about how the other fields of engineering have some common concepts that apply to all fields of engineering, and how can we look at learning through that lens, et cetera, et cetera. But it was also the networks, and I encourage listeners to join IEEE ICICLE. You can go to IEEE.ICICLE.org and find out more, because a lot of the authors were part of that community. And you can interact directly with many of the authors and the experts in learning engineering by joining that community.
Jim Goodell is co-editor of Learning Engineering Toolkit, evidence-based practices from the learning sciences, instructional design, and beyond. In the show notes for this episode at leadinglearning.com/episode 331, you'll find the visual of the learning engineering process that Jim explained. You'll also find links to the toolkit, ICICLE's web presence, and Jim's Twitter profile, as well as other resources related to our conversation. At leadinglearning.com/episode 331, you'll have options for subscribing to the podcast, and we would be grateful if you would subscribe if you haven't yet. Subscriptions give us some data on the impact of the podcast. We'd also love for you to rate us on Apple Podcasts or wherever you listen, especially if you enjoy the show. A quick rating doesn't take long, but it's very valuable because reviews and ratings help the podcast show up when people search for content on leading a learning business. Finally, we hope you'll spread the word about Leading Learning. At leadinglearning.com/episode 331, there are links to find us on Twitter, LinkedIn, and Facebook. Thanks again, and see you next time on the Leading Learning Podcast.